We're going to finish up now talking about Kepler's three laws of planetary motion. The mathematics here is a little bit more complex, so I might go a little bit slower. But one of the interesting things about Kepler's laws of planetary motion is how he decided or came about understanding how the planets moved. It was always believed until Kepler came along that planetary orbits were circles, and it was thought the circle was the most perfect form, and that, you know, if God was going to make a planetary path, it would be a circle. But one of the problems is that the math didn't work. Every year the planets would not be in exactly the right place where they were supposed to be based on calculations using circles. And Kepler did not like that. He felt like that, you know, he shouldn't have to correct God's work every year because the paths didn't work out. And in a stroke of true genius, he realized that what was wrong was the fact that the planetary motion was not a circle, but an ellipse. And an ellipse is a closed curve that is created such that the sum of the distances from a point on that curve from two different foci is a constant. So every ellipse has two foci, and those two foci are called F1 and F2. Now, in a planetary situation, F1 is where one of the two planets is. In this case, it would be the sun. And the other is somewhere else that does not correspond to where M is. But if you add the distance from M to F1, so from M to M, and this distance from F2 to M, that will always be a constant. And the way you do that is you have a string that is a constant length. You put the pencil in and you just start going around, and it will change, but the sum will always be the same. And a circle is simply a special ellipse in which the two foci are on the same spot. So here, for any planetary motion, the M path is the path of the planet, the small m, and the large M is one of the two foci and represents the sun. And Kepler's first law states this fact for the planets orbiting the sun, that Kepler's first law states that the distance from the planet to the sun and to another focus, that sum of those two distances remains a constant. So when the planet's over here, you have a very short and a very long. When the planet's over here, it's very short and very long, but the sum is always constant. It traces out an ellipse. Now the second has to do with these various areas, A1, A2, and A3, and the path that the planet takes. The shaded regions are regions of equal area. So you have the first is here, the second is here, and the third is here. And remember that these shaded regions represent various angles of displacement along the path. The Kepler's law states that when a planet orbits, that A1 is equal to A2 is equal to A3. Thus, the velocity, the mass, has to be faster for A1, medium for A2, and more slow for A3, for these areas to all be equal. And so the second law states that when the planet is closer to the sun, its velocity is increased, and when it's far away from the sun, its velocity is decreased. And that's the second law, Kepler's second law. you can understand pretty quickly, if you think about it, just how complex the mathematics has been to discover this. And the third law is stated right here. That is, this is stated is the square of the periods of any planets. So for example, here, let me get this right for you. So for example, if you look at the period for Mercury and the period for the Earth and square those, so how long it takes the Mercury to go around the sun and how long it takes Earth to go around the sun, you square those periods, and that ratio is equal to the average radius of curvature cubed for Mercury divided by the average radius of curvature cubed of the Earth. So that, again, that's a very complex mathematical derivation, but it turns out to be correct. So that ends the discussion, and it also ends the lectures for the first quarter. We'll discuss this material on the 17th of October. The quiz will be due on the 19th, and the final examination will be sent out the same time that the quiz is due. You can turn the final examination in any time between Friday, October the 19th, and the next Friday, October the 26th. What that means is that if you choose to take a fall break, then you would want to do the examination before you leave so you can have a vacation, or you can choose to not take a vacation and use that extra time to study. But I have to receive all materials, which includes any homework that hasn't been turned in, by October the 26th. Anything comes in after that would be considered late. If it's homework, it gets a 0, and if it's the examination, it gets a 10% deduction. And the quiz will be due on October 19th. This will also be explained in an email, so don't worry about that.